Hi everyone, my name is Baran Koseoglu. I'm a researcher at Behavior Analytics and Visualization Lab at Sabanci University. Today I would like to present our study called ST Sequence Miner, Visualization and Mining of Spatio-temporal Event Sequences. Event sequences, as we all know, are sequences of time-stamped observations, each described with a set of features. The observations made in a sequence are not necessarily ordered by time, but here you can see such an example. On the right side you can see that the person starts initially at home, then she goes to shopping, then she goes to a restaurant to eat lunch, and then she goes to watch a movie. Our motivation behind the study is the current practice of analyzing event sequences in the industry. The practitioners start with writing their queries. Once they are satisfied with the initial results and their observations, they move on to the next step, where they implement some rules. These rules are used to set some flags when certain conditions are met to capture event sequences. Then there comes monitoring phase. They monitor these rules, and if they work, if they are not satisfied with the results, then they go back to the first phase and repeat this process. As you see, this process is rather time consuming and it doesn't really give much in terms of exploration. So we want to really combine these two elements together, where on the one side we know that the humans are great at generating insights from the data, and computers are obviously good at solving automated tasks and problems. And so we want to combine these two elements to build a vision analytics tool. We would, at the beginning of the analysis, we were hoping that it would give better insights because we really merged these two elements together. And it's an exploratory approach where humans are always in the loop, so they can give feedback, they can tune the algorithm, they have the control over the algorithm, and they can generate better insights. Obviously, such a tool requires a user-centered design. User-centered design, we used follow these 4 stages, but obviously depending on the project, these 4 stages can be expanded or they can have less components. First, we defined what user needs, and we defined what they mean by saying event sequences. Then later we decided on the requirements, tasks and goals required by such a system. Obviously always talking with the experts. Then we built our tool. We make several versions of the tool, so until the final version we iterate this loop over and over again until we are satisfied, and we make sure that the tool actually captures all the requirements, tasks and goals. The data we had in our study has 4 million credit card transactions of over 60,000 customers of a bank in an OECD country. There were 31 event categories, and we grouped them to one of the 9 categories that we decided with the bank specialists. Variables in the dataset include customer identifier, timestamp, location, transaction amount, and merchant category code, which are typical transaction variables. On the right side, you can see transaction length and frequency of the customers. The period for this graph is 1 month, and you can see that some customers are probably using only this bank and are loyal, but some of them have probably multiple banks. At some point, these customers becomes noise for the analysis because they really behave different than the loyal ones. So we decided to remove some of these customers based on their transaction length. Before building ST-sequence miner, we set analytic goals and tasks required by such a system. With the help of bank specialists, they said they would explore data from different aspects. They both want to explore customer level based on expenditure and different event sequences of different event types. They also mentioned that they would want to compare different event sequences such that we would require a semantic summary of such event sequences on the graph. They also added that they would want to go from a grouping of such event sequences to individual event level examination of those sequences. When building ST-sequence miner, we had some challenges. These challenges can be categorized into two. The first type of challenge was related to data. We had high number of event types. That's why we need to reduce those event types applying a grouping technique with the help of bank specialists. Our data was multivariate. That's why we designed our tool having time series graph and a map component. Event sequences in our data had also different lengths. That's why we removed some of these event sequences as they become noise after some point. And this type of challenge is not specific to our study. Usually in vision analytics, there is a trade-off between information gain and complexity of the tool. That's why we need to balance these two together to give as much as information we can give to the user in a less complex way. Here you can see a quick demo of ST-sequence miner. As you can see, it had multiple components. Users can select event types, can also supply gap constraints to the mining algorithm, and can select customer types. As you can see on the left side, pattern view is already populated with patterns mined from entire dataset. In the middle, you can see location and time series graphs. On the right side, you can see density plot, which will be updated when my algorithm finishes, and the hierarchical view will also get updated. Sequence view will also be populated when the algorithm finishes. Let's select some event types and a time range. We can also specify specific region. As you can see, ST-sequence miner mines event patterns from the event sequences on the subset of data. The maps get updated. The density plot shows event categories and their respective frequencies. When a pattern is selected from pattern view, hierarchy view gets updated. And when one of the sequences from sequence view is selected, user can see details of the sequence. As we saw in the demo, a typical user flow is like this. So the user selects time and location. She can also provide some parameters to the mining algorithm. Then the mining algorithm, given user inputs, given the parameters, mines the event sequences and populates pattern view. We can also see the respective frequencies of event types in the subset of data. Then once the pattern, one of the patterns in the pattern view is selected, hierarchical view groups these patterns based on the event types on respective days. And sequence view gets populated as well. Once one of the sequence in sequence view is selected, the user can see the details of the sequence, both on the map and as a summary in the transaction detail view. We conducted 2 sessions with CRM specialists of the bank using insight-based approach by North. The data analyzed in these sessions was restricted to 1 month period of the actual dataset. We assigned 2 different tasks to participants and recorded these sessions, where the first task was to use ST sequence miner to explore frequent patterns from dataset, and the second task was to design marketing campaign strategies based on these frequent patterns found in the first task. Results was like the following. So participants discovered various event patterns during the course of the study. We recorded 23 insights, 7 questions, and 6 hypotheses in total. The participant further stated that they could use ST sequence miner to offer customized offerings based on the individual profiles of the customers. They also added that they could utilize ST sequence miner as an exploration tool before building machine learning models. This would obviously lead to engaging with data in a higher depth, and as a consequence, the accuracy of the predictions of machine learning models can be higher due to better understanding of the data. Finally, future work includes the following. We currently support user control over the parameters of the algorithm used in ST sequence miner, but this control is limited. We plan to provide more control to the user over this parameter space by means of using a recommendation tool. Discretization of time and space has some impacts on the quality of patterns mined. We currently have day as a time unit and kilometer as a distance unit. We plan to measure the impact of the discretization of time and space on the quality of patterns mined in the future. And lastly, some event types can be more critical than the others. We plan to put this information into the mining algorithms used in ST sequence miner. Thank you all for listening.